Welcome students. Here we are going to discuss this topic, algebra of sets, and under this topic we will discuss a very interesting law which is known as complement laws. There are two parts, so it is known as laws. Okay, so that is complement laws. Complement laws. So let us see complement laws here. First law is A intersection A complement is null set. Second is A union A complement is universal set. Third law is phi complement. This is universal set. And fourth one is U complement. This is equal to phi. Now let us see proofs of these laws. Very interesting proof we have here. Proof. We'll start with proof of the first law, which is A intersection A complement is equal to null set phi. Here we'll be using very simple properties of set theory, and these properties are: if X belong to set A implies that X belong to set B, it means A is a subset of set B. You can write here, then A is a subset of B. And another property of set which we will use here is, if A is a subset of set B and B is a subset of set A, then these two sets A and B will be equal. So let us start with this property. Let us suppose that X is any arbitrary element of left hand side, and we will try to show that this arbitrary element X is also belonging to null set phi. Okay. So let X is an arbitrary element of LHS. X is belonging to A intersection A complement. This implies that if any element X is belonging to intersection of two sets, it means X is belonging to both the sets. Means X is belonging to set A and X is belonging to A complement. And we can write here, this is X belongs to set A, and if X is belonging to A complement, then by the definition of complement, A will not belong to set A. So X will not belong to set A. But there is a very big contradiction. Here we are writing X belongs to set A. Here we are writing X does not belong to set A. So there is no such element which can belong to set A and not belong to A. Very contradictory. So this is a conclusion that X belongs to null set. Means there is no such element which belong to A. So naturally X belongs to null set. Means there is no such element. That's why, although null set is empty set, so X belonging to null set, it means there is no such element. So what we are getting here, we have started from left hand side and we are coming here right hand side. So by this definition, if X belongs to A implies that X belongs to B, then A is a subset of B. So here X belongs to LHS implies that X belongs to RHS, means LHS is a subset of RHS. So therefore, we'll write here, therefore we can write that here A intersection A complement is a subset of null set. Suppose this is relation number 1. Again, We'll start with the right hand side. X is any arbitrary element belonging to null set. But this is not possible because null set is empty itself. So in spite of writing this step, we can use a property here that we know that null set or phi is a subset of every set. Subset of every set. It means null set, empty set is a subset of this set also. A intersection A complement, relation number 2. So what does it show? Here LHS is a subset of RHS and RHS is a subset of LHS. So by combining these two results, these two relations, by combining 1 and 2 using this property, if A is a subset of B and B is a subset of A, it means A is equal to set B. So by combining 1 and 2, we can write LHS is equal to RHS, means A intersection A complement is equal to phi, null set. I hope you have understood this condition. Here LHS is a subset of RHS, means this set is a subset of null set, and here RHS is a subset of LHS. So by this property, if A is a subset of B, again B is a subset of A, then these two sets are equal. So here this set is subset of null set and null set is a subset of this set. So this set is equal to null set. So this first law has been proved here. Correct? Now this is very simple. Okay. So now we can do this second part also very easily. Let us see proof of this second law. Second law is A union A complement, this is equal to universal set. You know what is universal set? Universal set is the biggest set under consideration. This is the superset and other set are subset of universal set. So by the same process, let us start. Let X belonging to left hand side, A union A complement, and this implies that X is belonging to union of two sets. It means X belongs to set A or X belongs to A complement, and this implies that X belongs to set A or X belongs to A complement, means X will not belong to A, or X does not belong to set A. Correct? So just you can imagine here statement is X belonging to A or X is not belonging to A. In both the cases, X will be a member of universal set. Correct? Or in other words, you can say that every set is a subset of universal set. So this implies that X belongs to universal set. Or you can write alternatively, or as every set is a subset of universal set, therefore we can write this set will also be subset of universal set. So A union A complement is a subset of universal set. Let us write it, relation number 1. Correct? And now we will show that here we are showing LHS is a subset of universal set. Now we will show that universal set is a subset of LHS. So next, let us suppose that X is an arbitrary element of universal set. So this implies that if X is a member of universal set, so we can write X belongs to either A or X belongs to its complement. X must be somewhere, either in A or in A complement. Then only this is available in universal set. Okay? And this implies that X belongs to A or X belongs to A complement means X is belonging to union of A and A complement, isn't it? So this implies that X belongs to A union A complement. So here we had started from right hand side, X is belonging to U. We are coming to left hand side, X belonging to A union A complement, isn't it? So what does it show? Therefore RHS means universal set is a subset of LHS, A union A complement. Call it relation number 2. Here LHS is a subset of RHS and RHS is a subset of LHS. So sets in LHS and RHS will be equal by this property. If A is a subset of B and B is a subset of A, then A is equal to B. So again we can write here that by combining 1 and 2 we get A union A complement is equal to universal set. So this second law is also proved here. Very nice, understood. Now we have to show that phi complement is universal set. So let us see the proof of third law here. The pattern will remain same. We'll follow the same pattern here. We'll show that LHS is a subset of RHS and RHS is a subset of LHS. Then both the sets will be equal. Proof of third law. Here phi complement is equal to universal set. So as every set is a subset of universal set, therefore we can write this is also a set, phi complement is a subset of universal set. Relation number 1. Here LHS is a subset of RHS. Now let us start with right hand side. Next let X belongs to universal set. This implies that X does not belong to complement of universal set. X does not belong to complement of universal set. Okay? Here we have to show that universal set is a subset of phi complement. Here X belonging to universal set shows that X does not belong to complement of universal set. And you know complement of universal set is null set. Means complement means subtraction of that set from universal set. So universal set will be subtracted from universal set itself. So that is null set. So this implies that X does not belong to null set. And again, if X is not belonging to this set, X will belong to its complement. So you see, here we had started with right hand side, X is belonging to universal set, and we are coming here left hand side, X belonging to phi complement. So RHS is a subset of LHS by this property. So therefore universal set is a subset of phi complement. Relation number 2. And now you can use this property. A is a subset of B and B is a subset of A, then A is equal to B. Here LHS is a subset of RHS, here RHS is a subset of LHS. So LHS is equal to RHS. So therefore by combining 1 and 2, we can write phi complement is equal to universal set. So third law is also being proved here. Now let us see fourth law, which is universal set complement is equal to null set. Let us start with X is any element belonging to U complement. This shows that X does not belong to, if X is belonging to universal complement of universal, it means X will not belong to universal set, because we know that any element will belong to one set, it will not belong to its complement, and if the element belongs to its complement, it will not belong to the set itself. So here X is belonging to complement of universal set, it means X is not belonging to universal set, correct? But we know that every element belongs to universal set. It means there is no such element which is not belonging to universal set. So there is no existence of such element. So we can write that then X belongs to null set, because there is no existence of such element. In fact, we know that phi set, null set is always empty set, there is no element. But in this step, if there is no existence of this element X, means this can be a member of null set. There is no existence. So here we are finding X belonging to U complement implies X belonging to null set. So by this property, U complement is a subset of null set. So therefore, U complement is a subset of null set. Let us write here relation number 1. Okay. Next, here we are showing that LHS is a subset of RHS. Now we will show that RHS is a subset of LHS. So here we have to show that RHS means empty set is a subset of universal complement. So by the definition of null set, by the property of null set is a subset of every set, as null set or empty set is a subset of every set. Therefore we can write empty set is a subset of this set also, because this is a subset of every set. So this is also a set. So we can assume that null set phi is a subset of this set, because null set is a subset of every set. Now here LHS, this LHS. Here LHS is a subset of RHS, and here RHS is a subset of LHS. So by this property, if A is a subset of B and B is a subset of A, then A is equal to B. So by combining 1 and 2, we will get the result. By combining 1 and 2, we will get LHS is equal to RHS, means complement of universal set is equal to phi empty set. Proved. So these are some very simple but very basic laws which are known as complement laws. Why these are known as complement laws? Because these are based on complements of set. Okay, and hope you know very well what is the complement, isn't it? Let us make it very clear here. What is complement? Suppose set A is having element 1 and 2, and universal set is having element 1, 2, 3, 4 and 5. Then how we will get A complement? A complement means universal set minus set A. Universal set minus A means universal set is 1, 2, 3, 4, 5 minus set having element 1 and 2, A. So here these two elements 1 and 2 will be removed here. So A complement will be a set having elements 3, 4 and 5. So this is the very basic concept of finding
complement of any set, and these laws are based on complements of sets. Okay, so these are known as complement laws. So hope you have understood it very well. Questions, these laws are very simple. So but this is for a fun in mathematics. Of course, these are generally not asked in the question, but sometime in objective question may be asked. Okay, so you have to understand these laws. However, proof of these laws is not very important. So students, please keep in touch with my videos and enjoy learning mathematics, and hope you have subscribed my channel. If not subscribed yet, please do it immediately and enjoy mathematics. Thank you very much.